Hello friends, today we are going to discuss a topic from a question from CSI in June 2019, and the question or topic is from the pedigree analysis. As per our information, they have given us a chart, and this chart shown that there is a problem or a disease that has been created from they have thrown a question to us that what kind of disease it may be. Firstly, we have to read the question before we going to discuss it. A family was examined for a given trait which is represented in the pedigree shown below. They have given us a trait which I have already told that they have given us a pedigree chart. Further, the degree of expression of the trait is highly variable among the members, and the disease they have shown in this chart is not similar type of disease. This is a variable they have shown in the chart. Some are only slightly affected while others develop severe symptoms at an early age, and the disease which have been created in this family chart, that some people are slightly and some are severely affected in their early ages. And they have given a following explanation that if what kind of disease it may be: A, X-linked dominant mutation; B, X-linked recessive mutation; C, mitochondrial inheritance; or D, variable expression can be due to the heteroplasty. And they have given that the four option: one is A and D, 2 is C and D, 3 is only B, and 4 is only A. So as per this question, X-linked dominant mutation, X-linked recessive mutation, this kind of terms, I hope the students who have already appeared or who want to appear in the CSI net, they are quite known about this term, and mitochondrial inheritance also. But they have given us a term that is heteroplasty. The heteroplasty is the term that is maybe unknown to many of us. That's why I have discussed in the left side of the heteroplasty. Heteroplasty is nothing but the presence of more than one organelle or genome. Organelle is genome. Organelle is genome means our DNA or nucleus contain DNA. We all know that, but in except our nuclear DNA or cell DNA, we have also our cell contain also many organelles that contains individual DNA, like mitochondria. Plastid is absent in the human or animal. Plastid is only present in plant, we all know that. That's why the mitochondrial DNA may be present here. So mitochondrial DNA may be present, and it is an important factor considering that the severity of mitochondrial disease. So they have told about here that it is a mitochondrial disease because the mitochondria, I want to say one thing, that the mitochondria, if a male and female crosses and they give birth to a child, either male or female, the mitochondria comes from the mother, not from the father. We have to know that, because the sperm doesn't contain mitochondria after fertilization or during the implantation of sperm into the ovum. So the mitochondria comes from the mother. We have to know this thing very clearly, otherwise some basic knowledges, these are very necessary to clear these kinds of problem. And I hope round signaling in this pedigree is showing the female and square showing the male as per our information, as all we know that. And the box that is fully filled with color or fully black as shown here, it means they are diseased. So now we'll start the discussion. What should be the answer of this question and what is the solution of it? Firstly, they have given that it is a X-linked dominant mutation. If it is an X-linked dominant mutation, suppose they contain a disease XD, and as per dominant mutation, we all know that they got 3 children in their first generation, they have 3 children and all of their children are affected, as because one X is come from mother in male and female both. So I hope the diseased part has come here, so all of them are affected. It may happen. So up to this level it is correct, but when if and suppose the in here it is a male, so Y is come from the father, another X is come from the father, and another X is come from the father. So the two female and one male all are affected, and it may happen. But in the third generation, suppose they have XD, so in the third generation they have 3 children from the left. In this part we can see here, and all of their children are none of them are diseased. But it cannot be happen, because in case of suppose their mother is a complete normal woman, so one X come from the mother, they have 2 boys and 1 girls. So if Y come 2 boys, so they have no problem with their Y, because Y chromosome doesn't contain any kind of inheritable gene, so Y is remain unaffected. So this may be right. But if they have only one X chromosome of the father, they will come from the father, and this one X chromosome is affected, so these children should be affected, but they are not. So in the generation third, female or girl child should be affected, but we did not see here that she is affected. So as per our discussion, we can easily say that it is not a X-linked disease. So X-linked mutation cannot be the true. So option number A is discarded. So option number A is discarded. So option number A, where we can find that option number A, it cannot be right. So option 1 cannot be taken, option 4 cannot be taken. So there are 2 options in our hand, C, D and B, and they have given the second option, that is X-linked recessive mutation. So we have to discuss what is X-linked recessive mutation. The second chart, if it is an X-linked recessive mutation, so both the X chromosome are affected. Suppose both the X chromosome are affected, so they have, and I hope the male also should be affected, because otherwise if it is a recessive mutation, so both the X should be recessive, otherwise the character will not show the recessive mutation. So but here the male is not affected, it cannot be happen, otherwise the 3 of their childrens all are affected. If suppose he is normal and her wife is recessively X-linked recessive, so he carrying 2 types of gamete and he carrying only 1 type of gamete, so it cannot be happen that XD and X if come here. In case of girl children, they should be normal or they are the carrier, but they are all recessive, they contain two girl children, both are diseased, but here we can found that they cannot be diseased, they should be a carrier. Both the girl children's girl children's both the girl children should be the carrier of the disease, but they all are diseased. So it cannot be happened, as because we have shown that uh, there are two girls and one boy. Boy, as because the boy is containing Y chromosome, so it may happen that Y is come from the father, and one XD, that is also come from the mother if X-linked disease. So it is also not, it may happen because the X is diseased, so the boy may be diseased. It may happen, it can be correct, but the both the girl child are should be remain normal, but they showed that both the girl child is affected, so it cannot be happen. So option 2 also should be discarded. So option 2 should also be discarded, so we cannot take the option 2 or B number of option, that it is a X-linked recessive mutation. So B and also we cannot take this to the option number 3. So we have to found that mitochondrial disease is the number C option. And what is mitochondrial? We have already discussed that mitochondrial DNA always come from the mother. So if male child or female child, in both the cases they all found mitochondria from mother. So now we can start our explanation in the case of the number 3 cases. We have seen here that mother is affected. It is not X-linked dominant mutation, it is not an X-linked recessive mutation as we have discussed before. So mother is affected, all the boys and girls of the first generation is affected. So we have already shown here that mitochondria comes from, in male and female, from mother, so all their child should be affected. But this is a boy child, he is married to a normal girl, and all of his children in the generation 3 is normal. It may happen because it is a mitochondrial part they found from his, or it has come from his mother. So but it cannot be transported to his children, as because mitochondria cannot go from him. It should it is obviously will go from his wife, so all of his children is remain unaffected, they are normal. Number 3, there is no option. Number 4, mother is affected and all of his children are affected, so it shows that it is a mitochondrial origin, as because the mother is affected and all boys and girls, 2 boys and 2 girls we have found in the generation 3 from the number 4 mother who is married to a normal man, but in spite of that all of his children are affected. From in the third generation, number 7, the woman is affected, but she is married to a normal man. In spite of that all of its children in the generation 4 is affected. It means, or it showed that the chart that if the mother is affected, then all the children, no matter if it is a boy or a girl, all are affected. so we can easily say that it is a mitochondrial DNA or mitochondrial part which come from his mother. So all of their, if from the very beginning of the first generation, if mother is affected, all of his children are affected. So we can easily say that mitochondrial inheritance may be one cause, and it is a right answer. Number C should be the right answer. And we have already found that heteroplasty, we can found variable expression of heteroplasty, and heteroplasty is nothing but the mitochondrial inheritance. They have reversely tell us about the presence of more than one type of organelle or genome, that is mitochondrial DNA, or it may be the mitochondrial genome. Heteroplasty also shows the mitochondria. So number C and number D is the correct answer, because heteroplasty showing the more than one organelle or genome that can come from mitochondria or plastid is absent in human, we all know that. And mitochondrial inheritance, what we have already discussed. So we can easily say the number 2 is the correct option. So from this discussion we can easily say that option 2, C and D is the correct answer. So thank you guys for watching this video. Please click the like button and don't forget to subscribe my channel. Thank you very much.